Good afternoon, how are we doing? Day one, GOTO, woohoo! Sunday afternoon. Oh. So yeah, that was a fun one to explain to my wife. I'm just going to be traveling to, anyway. Welcome, I want to talk about human beings. So who here is a developer? Nearly all the hands went up. Who isn't a developer? Okay, are you all sort of managers? Are your causes of work in developers? Yeah. Or you coach developers? Okay, so if you're in Martin's talk this morning, it's brilliant. I love Martin's talks. And he started off with, so he's coming out with some quotes about, that we sort of think of as fairly modern in terms of software. And he's saying, Alan Perlis said this in 1967, and Melvin Conway said that thing in 1968, and all of this stuff's like, we've been there before. I want to sort of do something a little bit similar. I want to go back in time. I want to talk about what it used to be like to be a developer, and how that's changed over the years, and what that means for us, right? What that means for us as developers. So let's go way, way back. Let's go back to the Old Testament. Okay? So in the beginning, well, not all the way back, 1844. Does anyone know what this is? One hand went up. Go on, what is it? No, the other Lovelace. This is a reproduction of, so this is all of the software in the world in 1844. This is arguably the world's first computer algorithm. So the story is Charles Babbage, who's invented this computing engine, this arithmetic engine thing. It's made out of steam and goats and stuff. And he's explaining to people how it works and what it does, and that you can get it to do calculations. And there's this young Italian guy in the audience who went on to, it turns out, to become the Prime Minister of Italy. But he's making notes, and it turns out he's making notes in French. I don't know if he's showing off or what, but he's making notes in French. And so a little bit later, Charles Babbage decided it might be useful to have this translated, so then he's got notes of his talk. So he asks a young lady, her name is Augusta Ada King Noel. We know her better as Ada Lovelace, the Countess of Lovelace. She is the daughter of Lord Byron. Lord Byron, famous for being an opium fiend and poet. And so, anyway, Lord Byron's sort of run off and gallivanting with all these women. And so his wife said, right, there's no way his daughter is going to grow up to be a poet. So we're going to teach her engineering and science and maths and stuff. And so Ada Lovelace had a very unusual education. She was educated in a very scientific way. And so she took on this job of translating this stuff for Charles Babbage from French. And on the way through, she made some notes. And they were very originally called notes. So all of the notes are just as notes. And note G, which was the previous picture, that is her making a notation of essentially how you could teach this analytical engine to do Bernoulli numbers, to calculate Bernoulli numbers. So she saw that you could take a computing engine and give it instructions and make it do stuff. Okay, no tests. Okay, just going to put that out there. But, they didn't have a computer, so that's fair enough. So this is 1844. This is all the programmers in the world. So that's two things. Firstly, all the programmers in the world were female. And secondly, all the programmers in the world really knew how to dress. Right? They were all saying in T-shirts and shabby jeans and whatever. And she's like, that's quite an outfit. So, okay. So time passes, okay? Does anybody recognize that? Any hands going up? No, you have a couple of hands. So one of my favorite games of all time from the 1980s, it's The Hobbit adventure game, and you type in things. And it said, and if you typed in wait, it said, you wait, time passes. And if you were with Thorin, Thorin waits as well, which is kind of nice, you know. Thorin doesn't just walk off and leave you, Thorin waits with you, which is nice. So 100 years later, okay, it's now 1944. Things have gotten a bit serious now. So the idea of a computer has become, and as with many of these things, and again, Martin alluded to this morning, most technical innovation tends to start in the military. It tends to start in defense, and then it goes into academia, and then it goes into commerce, it goes into business. And so, for instance, the internet started as an exercise in getting computers connected to each other by DARPA, the US Defense Advanced Research Projects Agency, and it was originally called ARPANET, and then it went into universities, and it was called JANET, the Joint Academic Network, and then we knew it as the internet. So computers are being used to crack codes, okay? So this is 2 women, because again, all of the programmers at the time were women, and these women genuinely are hackers, right? Because they're hacking the Lorentz cipher, the crypto that went into the Enigma cryptography machine. So, according to Wikipedia, the fountain of all knowledge, this is Dorothy Dubuisson and Elsie Booker, who are a couple of early programmers. And so necessity is the mother of invention, and then what happens? Then we invent tools. So this is Admiral Grace Hopper, one of my heroes. She invented the compiler because she had to, because it sucks not to have a compiler. There's a wonderful interview with her on a chat show, and I can't remember who's interviewing her, but he says so they hired you because what, you were a computer expert, and she's like, there weren't any computer experts. We were inventing this stuff as we went along. So she invented the compiler. She also invented the nanosecond. I don't know if you know about this. So what she was doing, she was trying to explain to other admirals in the US Navy and US military in general. She was saying, you can't have instantaneous communication with your ships at sea because space, right? And they said, well, what, I can pick up a telephone and blah. And she said, no, let me explain. And so she phoned down to the machine room. She said, I need you to cut me off a bunch of lengths of wire about that long. Okay, and so 100 lengths of wire. And so she would walk around with these lengths of wire around her neck. And when she was in a meeting, she'd say, here, have a nanosecond. And she'd pass one of these lengths of wire. And it's like, what's that? That's how far light travels in a nanosecond. And so then she'd say, right, so now what happens is this. When you send a message, the light travels in nanoseconds, so we've got to lay these things out, yeah? So every one of these, all the way up to the ionosphere and all the way back down to the ship, right? Every single one of those is a nanosecond. That's the shortest possible time you can have communication in. And they were going, oh. Oh, she also had some microseconds as well, but they were much longer. They're big coils of wire. And so we invent tools, and then, okay, so now we've got some tools, and now people start to specialize. So this is now, we're in the 60s, and computing has become simple enough, even men can do it. And so we've got these 2 guys here debugging a mainframe. This is in academia now. And of course, pair programming, which is nice, right? So, you know, they got into that pretty early on. And so people start to specialize, and so you get into these different kind of specialisms. So it wasn't just come in and fix stuff. It was, well, you know, we've got the idea of an analyst and a programmer and whatever else. And so we got commandments. Okay, so then we start to lay down rules, and we'd say things like, you shall have a business requirements document. Okay, because this is what we do. When we take things into industry, we like to put rules around it. And we say things like, you shall have a functional specification. You shall program in the manner of the specification. Okay, you shall have no other specification before me. Okay, there is one truth, right? And you code to that truth. Analysts shall analyze. Architect shall architect. We have these silos of specialism. And then we say programmers shall program. And by that we mean take a detailed functional specification and turn it into code. It's like an in-tray, out-tray kind of thing. And then testers shall test, which is taking the crappy code and turning it into bug reports, right? Similar sort of deal. Okay, there's more. There's more commandments. It doesn't stop there. You shall complete a formal change request. You don't just go, this could be better. I think if we, you know, if I brought my baby in and put it at my feet and figured out how to land a rocket on the moon, right, I could probably, no. no. Do you have a functional specification? Do you have a formal change request for that? No, I don't. You shall provide release documentation. Okay, you don't just get to put stuff into production. You shall not release to production yourself, lest you incur the wrath of the release manager. We still have that one. That hasn't gone away. You shall not hack on that which is in production. More of a guideline, really. But then, and this was my early career. This is probably up until, I don't know, 98, 99. I started programming. I'm much younger than Martin. I started programming in the mid-80s. Okay, about 2 years. But like professionally, well, not professionally, but as a graduate, probably 91 onwards. So throughout the first 10 years of my career, this was normal. This is how you did work. and then stuff happened. Right? Then we got the New Testament. And this was around about 2001. There was a new covenant, a new deal, a new contract. This is, Linda Rising famously calls this the Council of Middle-Aged White Guys, which I quite like. This was Bob Martin, late 90s, early 2000s. He knew a bunch of people, and all these people were trying to solve similar problems, okay? They were... Essentially, what they were trying to do was help teams deliver stuff in big companies. And what they would tend to do is, we have these multi-year, massive programs of work. And various different people had these guerrilla approaches. And these guerrilla approaches had names like XP, DSDM, FDD, feature-driven development, Crystal, Adaptive, Scrum, right? So all these, there's loads and loads of different methods that people have come up with and named. And he said, okay, this is great, but that's really kind of fragmented. We need an umbrella term. Let's come together and come up. And so they did. And it turns out that they actually tried this in 2000, and they all met up in a ski cabin in Utah, and they spent the weekend drinking whiskey, because that's what happens when you get 17 middle-aged white guys together. And apparently nothing happened. And so they went, oh, well, I mean, it was great fun, but nothing happened. So then the following year, they got together again, and this time they came up with a thing we know as the Agile Manifesto. So Agile Manifesto, I think it's a fantastically enduring document. Okay, if you stand back and squint, everything about this is true 15, 16, 17 years later. And I suspect it will still be true in 10 years' time. We are uncovering better ways of working is how it starts. It doesn't say, hey, we've solved software, we've done it. See, we got this. No, we're uncovering ways of working. It's an ongoing, it's a continuum. We value a bunch of things. We value processes and tools. Those things are important. We value individuals and interactions more than that. So the stuff on the right isn't rubbish. The stuff on the right is valuable. Otherwise, it wouldn't even have made it onto the sheet. But the stuff on the left is more important. That's what they're saying. We like comprehensive documentation because that's how people are going to understand what's happening later on. Famously, with at Amazon, whenever someone's going to start a new feature or a new product at Amazon, they start with what? What do they start with? Meetings, functional specification, BRD. They start with a press release. The first thing they do is they write the press release as though the product already exists and is awesome. And so they write this amazing press release and they go, right, shrug, let's go build that. Because that's a really, really good way to focus. A very good friend of mine, who's my favorite programmer, whenever he starts anything, he starts with the README. He starts with the README that he wants to read in order to build this thing. And then the second thing they do is they write the FAQ. Imagine this is already out there and is super popular. What would the questions be and how would we answer them? And I did this once. I'd written a thing like a little Heroku kind of rip-off, sort of an internal cloud deployment thing. And I was leaving the company and I was handing it over to my buddy and I started writing the documentation for it. I thought, because I don't want to dump it on him. And I wrote the README and it said, here's all the things you need to do to install this. And as I was writing it, it got to about 2 or 3 pages long. And I was embarrassed, right? And so I figured, right, well, what could I clean up here to make the README smaller? And so we ended up, so I iterated, it only took me a few days, but eventually this README went all the way down. It said, right, install this thing, change that thing over there and just choose a port number. So the whole thing you could configure with an IP address and a port number. And so I thought that was embarrassment-driven refactoring. Right? I couldn't look him in the eye and hand him this thing. I had to clean it up. So okay, so we've got this Agile Manifesto. and this changed a huge amount of stuff. Who's been in technology for less than 15 years? Okay, probably half of you, over half of you. So that means this stuff's always existed. For your whole career, this has always existed. So who's been around more than 15 years? All the tired arms go, oh, me, I have. Right? So you've seen this kind of sea change during your career. So revelation. Revelation is there's more going on. I'm now not a person who turns functional specification into code. Testers are not someone who turns deployed software in a testing environment into a bunch of test scripts and test script reports. We need to think beyond developer. Okay, we need to think about things slightly differently. So I'll tell you what I am now. I think of myself, I'm a multi-dimensional creature. I'm a developer, sure, but I'm a developer in a team. Okay, I'm not a developer on my own with my own little pile of work. I'm a developer in a team. I'm building a product, so I've got to start thinking about what it means to build a product. And I'm not building that product in isolation. I'm building that product on a platform. Okay, so that means I need to start thinking about the ecosystem I'm working on in the organization. I'm in a department. It's not just my team. This isn't a little siloed team-based thing. There's probably a whole bunch of teams working towards a single program. There may be a whole bunch of programs going on across a portfolio I've worked within a department, and that department exists inside an organization. So there's a bunch of stuff going on here, right? But I don't want to talk about me. I want to talk about you. Okay? Because you are all those things too. So what I want to do is unpack each of those things and have a think about how that impacts what you are, who you are, your identity, things that are going to help make you a more effective developer. Okay, so we're beyond this little silo programmer thing. So you're a developer. What does that mean? It means you need to start thinking about some stuff. Obviously, it means you need to learn the language. Right? Whatever language you're programming in, you need to learn that language. And there's learning and there's learning. Right? I can know roughly how to get by in C#. Right? I can figure out what to type. I can figure out that kind of thing. That might help. But then, for instance, C# and Java look very similar as languages. I'm much, much more proficient in Java because a language isn't just the syntax, it's the libraries. So there are some core libraries in that, and it's not just knowing where they are, it's knowing what they do, knowing what their performance characteristics are. Great example, Ruby has a data structure called list, and I can make lists in Ruby, and they're a list. Right? It has another data structure called set. In Java, I have a plethora of lists and sets, different types of those, for any occasion. Why? Because the sorts of problems that Ruby solves, it usually doesn't really matter what's going on under the hood. Right? By the time it does, you have to invent stuff like memcache, right? Because Ruby really wasn't designed to do the things that people try and beat it to do. Yeah? Ruby is a great prototyping language. It's a great sketching language like Python. They're really good sketching languages. They're really expressive. But again, they don't have an opinion about things like, so in Java, I could have a regular array list, which is a list backed by an array. I could have a linked list, which is typically going to be slower to do a bunch of things, faster to do a bunch of other things, much easier to, for instance, resize, insert things in the middle of, muck around with. Whereas an array list, I've got all of the behavioral characteristics of an array. With sets, I could have just a regular hash set, so I've got a bunch of buckets. I could have a linked hash set. I could have a concurrent hash set, which means it's got certain safeguards, which means it's safe under concurrent modification, which probably slows it down a bit, but means that it's safe in certain circumstances. As a Java programmer, I need to think about those concerns typically, and I need to choose the tool, the most appropriate tool for the job. Or, if I'm most Java programmers, I go, oh, hash set. Yeah, new hash set. Set equals new hash set. right? If you think about what's going on under the hood, it's what Martin was talking about earlier on. These algorithms and data structures, the fact the language has them, you should know what's going on in there. I had a conversation with Josh Block once, many years ago, who was one of the core early contributors to Java. So he wrote the Java 2 collections API. He did a whole bunch of stuff early on. And he said in Java 1.0, in fact, I think it was pre-1.0, the implementation of hash code in Java lang string was made a hash of the first 7 characters in the string. Now, the idea of a hash code is that it comes up with a number, and they use that number to put it in a particular bucket. And then what they realized is that most of the strings people were using in Java started with HTTP : //. And so your perfectly balanced hash set, your hash-based list of whatevers, everything was ending up in the same bucket, right? Awkward. Now, luckily, they didn't publish that implementation. What they published is it has a hash code and it has an equals, and this is the relationship between hash code and equals. So they could slide in a whole nother implementation of hash code for Java 1.1 and no one noticed. Yeah? And so be careful about the behavioral characteristics of what you're doing. So you need to learn the libraries. You need to know what's there. My brief forays into Clojure have been, which is a kind of Lisp that runs on the JVM, have been every time I do something in Clojure, I end up writing a bunch of code, and I look at the core libraries, and some code goes away, and I look at the core libraries, and more code goes away. So I do this, and then my code goes and ends up mostly being in the core libraries, because the people who design Clojure are much, much smarter than me. Okay? And so really a good way to become proficient in Clojure is to really understand what those core libraries can do for you, because there's a huge amount of power to weight in those. What else? It's not just about knowing your own stuff. It's about being aware of what else is going on out there. So JVM folks, who's been looking at Kotlin? Who's been taking a look at Kotlin? And obviously Scala and Clojure and some of those other JVM languages. There's a huge amount of stuff going on the JVM. It's a very exciting place to be. If you're in the .NET world, you're suddenly seeing like .NET Core on Linux. SQL Server just came out on Linux. Sentences I never thought I'd hear myself say in my lifetime. So understanding what's going on in your ecosystem, understanding what's going on elsewhere as well. So this is all a part of what you need to do as your day job. And it's not just about programming. It's not just about writing code, that intellectual masturbation we were talking about this morning. It's not just about I'm going to write beautiful code. It's I need to get this stuff live, right? So I need to know what the tool chain looks like for my language or for my technology stack. If I don't understand the tool chain, it limits me. It limits me in my abilities. And again, I don't exist in isolation, okay? So a big part of you being a developer now in the modern age, in the post-agile or in the agile, I guess, whatever age, is there is a huge amount of stuff out there, and engaging with the community doesn't mean copying some stuff I found on Stack Overflow, right, and upvoting it when it works, right? That's not engaging with the community, yeah? Meetups, any kind of gathering where you can go and learn, share knowledge, come into conferences. Everyone here is at a conference. Epic, well done, fab, right? So share your knowledge. Talk to people you haven't met before. Right, I know I'm saying this to Danes, and that's like, we don't even talk to our families. What are you talking about? So, but, try it. Just go and, walk up to somebody you've never met before and say, hi, where do you work? What do you do? What are you here for? What are you excited about learning? Okay, so that's what you do as a developer. But again, you're not just you on your own. You're a developer in a team. So what does that mean? That means you need to understand how work gets done. You need to understand what does the system of work look like in your team, right? And how could you improve that system of work? Understanding that we're not generic, fungible, exchangeable things. Each of us has a skills profile. Each of us has capabilities. But also each of us has interests. Each of us has aspirations. Each of us has stuff that they get really excited about. And also stuff that really, really bores us. And if you get me doing something I'm excited about, guess what? You'll get great work out of me. And if you get me doing something that sucks for me, then I'm probably not going to be at my best, however hard I try. So understanding the roles in a team. I think of this as 2 stages. The first stage is understanding what the different roles are, what people think the expectations are. And the second part, which I much prefer, is messing around with them a bit, right? And this idea of T-shaped people or M-shaped people or pie-shaped people or whatever, the idea that you can you're not just known for the thing you do. You know, if I take Martin Thompson is a Java performance specialist. That's most people say it's a pretty accurate description of Martin. He's not. He's a really bloody good programmer who happens to be working in Java and happens to get really excited about what happens close to the metal, right? That's him now. And that's him for the vast bunch of time. There will be other languages. That won't make him redundant or historic. And what it means is he'll go, oh, let me try and take all of this stuff I know and apply it to a completely new context. What if this were operating safety-critical machinery? How would that affect things? What if this were in a small mobile device? What if this were in a pacemaker? I don't know. So understanding the roles in the team and mucking around with those roles a bit. I'm sorry, kids. You have to learn to share your toys, right? Collaborating is really important. There's a bank, a well-known investment bank that I know they're American, but I know them in the UK. And when you first join there as a graduate, you know, they're kind of their graduate accelerated whatever development program, they do 2 things. They throw you together with a whole bunch of other graduates from all over the world, and they tell you there's 2 things that matter to make you successful at this bank. And they call it impact and influence, okay? Impact is what you can do. Influence is what you can cause others to do around you. So early in your career, most of what you'll do is impact. It's you being good at what you do and getting better at what you do and growing in that way. Later on in your career, it's about influence. So even if you're the best programmer in the world, there's only one of you, right? If you, as a good programmer, can infect other people, infuse other people with those habits, with those capabilities, you just became a 10x, 20x, 50x programmer. Yeah? That's how you scale. Kent Beck famously said, I'm not a great programmer. He said, I'm a good programmer with great habits. What makes him a fantastic programmer is he goes into organizations and teaches those great habits to other people. He is a 500x multiplier, right? So collaborating with others, being aware that you solve problems better when there's more than one of you. Pair programming isn't 2 people sitting at a computer programming. It's 2 people programming, okay? It's not one of you navigating and driving and all these crappy metaphors. It's 2 human beings collaborating to solve a problem. They happen to have a computer with them. But all of the magic happens by the fact that these 2 people are collaborating and disagreeing. Right, and maybe I'm pairing with I know on something, and she's solved this 100 times before, and so she says, okay, I know the answers, this is the answer. And I've solved this 100 times before, and I know this is the answer. And so we start working, and this sort of happens, and we go that way a bit, and then we go that way a bit, and then we end up sort of here, and we both go, whoa, that is so cool, right? Because we would never have thought of that, either one of us on our own. Yeah, and all of the software in my career that I've been really proud of, most of the software I've ever written that was any good, I didn't write. I was one of a pair that wrote it, but I cannot put my hand on my heart and say I wrote it, because I didn't. Okay. And not just people you like. Collaborating is about really reaching out, really getting to grips with all of the people in the team. Okay, so you may be very much a technical programmer. You like to be down in the weeds in the technology and all of that. And maybe the idea of, you know, I happen to be building a trading system. I happen to be doing healthcare. I happen to be doing finance. It doesn't really matter the domain because I'm really down here. You still need to collaborate with people towards the business side, towards the commercial side of the product you're building. That makes you a better programmer. That makes you a better developer. So collaborating with all the others. And again, it's not just about you. Say there's 6 of you in the team. If each of you is looking out for yourself, each of you has 1 person looking out for them. If each of you is looking after everyone else in the team, you now all have 5 people looking out for you. It's just basic maths, okay? So you attend to the team's health. Sometimes you pause and let other people go ahead of you. There was one team, I was working at a bunch of years ago in a bank. Most of my story is bank, sorry. And there was a particular manager who wanted to understand each individual team member's contribution in terms of story points. Okay, so we're going to measure everyone's story points and we're going to cull the weakest people in the team. And so there's a chap, I don't know if any of you guys have come across him, his name's Tim McKinnon, phenomenal developer and wonderful, wonderful coach, and all-round lovely human being. So he's in the team and he's coaching in his team, and his velocity was 0. Tim's personal velocity was 0 points. And so the project manager said, well, it's obvious, isn't it? That's the person we cull. And I said, no, you don't get to do that. The reason Tim's velocity is 0 is Tim never signs up for stories, because Tim knows he is much more effective pairing with everybody in the team. He is the minister without portfolio within that team, right? And so what he does is he accelerates the whole team. He is that 10x developer by not committing to anything himself. He enables the whole team to go faster. I said, if you take that guy out of the team, everyone on the team will slow down. You will cripple that team. And it took a bit of fighting, but we got to hang on to it. Yeah? So attending to team's health is a really, really important thing. There's a bit of a tail wagging the dog thing that happens even in some quite forward-looking organizations where they get a bunch of agile coaches, right? And the agile coaches come in and do agile coaching. And what that does, and particularly I see this in Scrum a lot, because you have this idea of a Scrum Master, and the Scrum Master's job is to remove obstacles. No, the team's job is to remove obstacles, because that's how you get work done. Right? But as soon as I have a person, I can absolve responsibility onto them. So with a product owner, I've got a product owner, so I can absolve responsibility of product thinking. I don't need to think that anymore. So originally, these were coaching roles, but we've lost sight of that, and now they become, the system's kind of gone back in the other direction, which is sad. So the team attends to the team's health. The team removes the team's obstacles, okay? So you're in a team. You're building a product. What does that mean? That means we need to start thinking about product. There's a parallel track going on about kind of lean UX and product development and all that kind of stuff. I hope you guys are taking the opportunity to kind of bounce between the two, because there's some gold in both tracks. It's really, really wonderful. It's a really well set up day today. Or it's a really badly set up day because you want to be everywhere, right? But I'm building a product, so that means I need to understand why I'm here. I can't get excited about something unless I know why I'm here. We hear all the time about how do I motivate my team? Well, give them something meaningful to do and they'll do the rest, yeah? If they don't have a sense of meaning, if you don't have a sense of purpose in your work, someone needs to pay you a lot of money to turn up. If you do have a sense of purpose, I was talking to someone earlier on about games, about the game industry, and an awful lot of particularly independent games development is just done out of passion. I've got this game in my head and I have to get it out of my head. If I don't get it out of my head, I'm going to explode. Right? How much do you want to get paid? I don't care. Get out of my way. Right? I need to build my game. Yeah? So you need to understand the business objective. What's the point of what I'm doing? Because if I understand the point of what I'm doing, I can start making trade-offs. I can start moving towards that goal. You study the domain. If you're building healthcare software, find out how healthcare works. If you're building banking software, find out how banking works. I'm working with an enormous German bank at the moment. And we're going through an exercise, and it's wonderfully life-affirming, where people who think their job is to move data from point A to point B, you suddenly say, well, actually, your job isn't to move data from point A to point B. Your job is to enable the flow of information so this guy can pay his mortgage. Or so this lady can have money arrive in her bank so that her family can eat, right, and do stuff, yeah? Your job is to create the mechanisms by which money flows through Germany. That's what you're building. You're building an entire system of finance for a country. And you look at it, and they are, right? And they suddenly go, whoa. They start taking it a bit more seriously, which is always nice to see in a bank. I always think it's quite healthy. But you just see the motivation. They're energized. They're like, I'm not doing this. I'm not turning this set of requirements into da-da-da. And they start to become much more empowered. And I'm I'm a bit in two minds about this word empowered, because empowered sounds like something you do to someone. I'm going to empower you, right? It's an asymmetry. No, you can empower yourself. You can decide you're going to go and do stuff. You can decide you're going to think differently about things. That's how one can empower. So we study the domain, and by studying the domain, that means we can understand, we can solve problems in that domain. You can't study a domain unless you know about the people, or unless you interact with the people who care about that domain. So if I am, again, building a finance system, I've got traders, I've probably got brokers, I might have some compliance people and legal people, right? Some security people. Who else might I have? Well, I've got the tech operations people and the support team. Right, those poor buggers who are going to have to run my software, yeah? We don't usually think of those, so we need to get to know all the stakeholders. Mark McNeil, who's one of my favorite UX people, he has this lovely phrase for stakeholders. He says, stakeholders are people whose lives you touch, right? Anyone whose lives you touch by doing work, they are stakeholders, okay? So anyone who's involved in the work you're doing. So those scary security people and the scary legal people, their lives are touched by the way you're doing work. A chap I know was working in another bank, and they were building a new system, and he said, I'm going to build security in. I'm going to build security in, rather than what we usually do, which is a security audit at the end, where they rip holes in it and they send us away for 3 months. I'm going to build security in. So he goes to the security officer, and he says, hey, security officer, can you tell me what I need to do to build a secure application? And the security officer said, sure, show me what you've got. And well, I haven't got anything. I haven't started. He said, no, you need to show me what you've got, and I tell you what's wrong with it. That's how security works. And he goes, no, I want to do it the other. I want you to tell me, because I'm good at software, but I'm rubbish at security. Will you explain to me how security works? And he said, no one's ever asked me that before. So he said, well, okay, let's figure it out together. What's the first thing I should know? And they started talking about like attack surface areas and threat analysis and threat modeling and risk and trade-offs and all this kind of stuff. And so between them, they built up collaboratively a body of kind of your idiot list for Security 101 for securing an application. And so that was a side effect, artifact of this product. And so the next time they came along with an application, someone said, oh, what about... And also, what it meant is that when they got to the security audit at the end, the review was a bit like this. You know all that stuff we talked about? Yeah. Did you do it? Yeah. On your way. Because they'd already been engaged. And so these people who are often gatekeepers, policemen down the line, they become upstream, it's a shifting left thing, they become upstream collaborators. They become consultants into your process. So getting to know the stakeholders there's a reinforcing virtuous cycle there. So you're learning about them, they're learning about you, you're figuring out how you can solve problems together. It's pretty exciting. And of course, you contribute to the product. I'm working for a retailer in the UK, one of my clients, and literally everybody who works there shops there. Okay, partly because they get a really big employee discount, yeah? But everyone who's writing code, everyone who's testing systems, all the product team, the back office, all of the commercial guys, every single person there shops in this store. So when they say, well, what would our customers want? Well, I can tell you because I am one. Yeah? And I go into their shop because I like their shop as well, and I try using their mobile app, and it's not great. It's not great. They're amazing brand, amazing products, pretty good website. Mobile products kind of okay. But they know this because they use it. And so what's happened is the mobile product in the last probably year has gone from okay to actually really pretty good. And because they didn't have meeting after meeting of business requirement documents and flowcharts and blah, they said, what do we want to be better? Let's go make it better. What's the next thing we want to be better? Let's get it in front of some customers and let's see what they think. So you can contribute back to the product. I'm asking you, this is a plea, this is a call to action. Everyone here who's in a development role is to shake off that mental shackle of we have requirements come at us. We are told what to do. In psychological terms, it's called being at effect. You can either be at cause or be at effect. If you're at effect, that means things happen to you. If you're at cause, that means you make things happen. So we tend to be at effect when it comes to requirements, when it comes to what we do in a product. Everyone here has a brain. Everyone here has empathy. I really hope. I mean, apart from the sociopaths, you guys are fine, right? Apart from the sociopaths, everyone here has empathy to different degrees. And so you can contribute to the product. I've seen probably some of the highest performing teams I've seen were in a trading firm I was working at a few years ago. And you had developers and traders sitting in amongst each other. And it was just as likely a really cool idea for improving the trading stack would come from a developer as it would from the traders. And over time, in fact, the traders, they knew their way around Excel anyway, but they started learning Python because it's a really easy language to learn, and it meant they could just sketch things. And once they were sketching things, they could say, hey, I've had this idea. I know it's really crappy code because I'm a trader, but what do you think of this? And then one of the developers would go, that's a really cool idea. I'm going to iterate on that. And they'd iterate on that and then turn it into a product, and it made a load of money. Right? So you get technical algorithmic ideas coming from traders. You get business ideas coming from developers because they both care about learning the domain, care about learning the product. And they contribute to the product. So we're building a product. We're building a product on a platform. In defense of WebLogic 6, which took a bit of a kicking this morning, so I too was using WebLogic 6 in probably 2005-ish. But interestingly, you see, and this really is to kind of feed again into what Martin was talking about earlier, is yes, we understand principles and things like data structures and whatever else. At the time, we were wrestling with WebLogic 6. There was WebLogic, there was WebSphere, there was Oracle had a product that no one even knew what its name was. And there were a bunch of these things, and all of them were equally massive, unwieldy, complicated, heavyweight, and all very clicky configurations. So you had to click on a really slow, ugly UI that would crash a lot and do bad things. And what we noticed was, behind the scenes, WebLogic was a Java app, and we pretty much knew our way around Java apps, and everything it did was XML. So what you could do is, and this is what we did, was you could install WebLogic and then just snapshot the directory, snapshot everything that just changed on your file system. And you got a whole bunch of XML files. And then you go into the config pages and start changing some values and then see what's changed. Do like a recursive diff, put the whole thing under version control. And that started to tell us where in these XML files those values were being stored. It wasn't a great leap to then take those values and tokenize them and then have an automated build process that would drop the values in for us. And so we had this idea of a template server. And so you could take a server, you could template it up, you could drop the values in, and now you had build time configuration completely automated. And a whole bunch of other patterns and techniques came out of that period. And a bunch of them were then collated into a book written by Jez Humble and Dave Farley, because Jez was on the team with me. I hired Jez. We were doing the build engineering side of WebLogic, and Dave Farley was heading up a bunch of development teams that were chucking stuff into it. And I guess, again, in terms of necessity being the mother of invention, all of these things turned into what we now call continuous delivery. So we can thank WebLogic for that. Because if it had been easy to use, that might never have happened. So, even when you're using these tools, you can be at effect, oh, this tool is horrible, I hate it. Okay, BizTalk, I have no love for BizTalk, right? There's nothing good came out of BizTalk. But, so a lot of other tools in technologies, you're in there and you're thinking, how can I make this easier for the next person to use, okay? So I need to understand the technical landscape within my organization. Right? I need to understand what the APIs are, what other technical platforms there are. I need to understand my path to production. We've talked about this already. So it's not enough to write code. I need to be able to deploy code. I then need to think about runtime concerns, monitoring, telemetry, instrumentation, alerting, and even prediction, Once you get to alerting sufficiently sophisticated, you can put a bit of machine learning on there, and guess what? You can start to predict when bad things are going to happen. Netflix does this with their Amazon stack. So I need to care about runtime concerns. As a developer, this is something I do in teams, is I put all of the developers, I rotate through the build role for a period of time. I find it makes them a safer driver, okay? I'm a huge fan of development teams carrying a pager, right? Because if someone's going to get paged at 3 in the morning, it might as well be you. Oh, now you're going to think twice about whether that's a warning message or an error message, aren't you? Because a warning message, you won't get paged at 2 in the morning. No. Okay? And usually it's someone else that gets paged, so we tend not to care about that. We value automation. Okay? We care about automation, but not all the automation. We can get obsessive with automation. Automation has a trade-off. It has opportunity cost. Automate things, automate repetitive tasks. My heuristic is automate it when it gets boring. Okay? Boring means you've done it enough times that you know how it works, and it's been similar enough times that it's boring now. If it changes every time, don't automate it yet. Once it becomes boring, that's a good time to automate it. And again, you contribute back to the platform. As you're learning things, you're feeding that back to the other teams, the other custodians of the other platforms. And you end up with, Dave Thomas calls these organizational APIs. You end up being able to communicate between departments or between groups through their APIs because you've got a robust enough business process modeled through those APIs. In a department, so what does this mean? This is that, remember I was talking about impact versus influence? This is the influence part. So you understand the wider context, okay, and you can make trade-offs. I'm in a position now where even though locally for my team or my program, this would get me forward, the right thing for the organization is to do something a little bit more sensible. Organizations like Spotify have this, this wonderful matrix model of tribes and guilds and whatever. That mostly exists to try and get some consistency. Okay, to try and create those communication channels, communities of practice, so that people can find out what's going on. It's a very, very clever idea. It breaks under really, really big scale, but there's other stuff you can do, right? And then now you're sharing your knowledge across teams. So you're maybe having like meetups internally, internal open source, internal conferences. One of the things I love about the work I do, I'm an independent consultant, I often get invited into companies doing internal conferences. Like really big companies often do internal conferences. And they're run like this. They're run very professionally, but it's just for their internal employees. And it's great because that's a clear message that we're investing in people. We're taking everyone out of their day jobs and moving them all to, I don't know, Berlin or Paris or somewhere cool for a couple of days, and we're going to geek out, right? Now, all of those people are now not at work, right? That's a really cool thing. So sharing your knowledge across the teams. All your knowledge. So when I first started out as a contractor, which would have been probably late 90s, I very quickly realized that there are 2 ways to be a successful contractor, to be a successful independent. One is to hoard all the knowledge. If you hoard all the knowledge, you're unsackable. Okay? The other is to share all the knowledge. Because if you share all the knowledge, people want you to be around. They like having you there. And I also learned, and this was during my ThoughtWorks days, there's a really interesting thing that happened, was this. You would go in there and you'd solve a problem and you'd make yourself redundant. And what happens when you make yourself redundant usually isn't go away. It's usually, that was pretty cool. Can you come and solve this other gnarly problem we've got over here? So you don't really make yourself redundant, you just make yourself available again. And then you go off and do something else. So I realized fairly early on I was going to have to choose one or the other, and I went with all the knowledge. So that's why I do this stuff. I love sharing knowledge. I'm a huge fan of sharing knowledge. I encourage it in others. You contribute to the department, okay? So this is now about care and feeding of the organization. I've seen really, really high performing developers move into people roles. So did they burn out as a developer? No, they realized that they could have a much bigger multiplying effect by helping loads of other developers, right? A lot of programmers I know who speak at events and things, they could be a lot more productive if they weren't speaking at events, right? If they were sitting there typing stuff, yeah? But you know what? They are trying to contribute to the wider group. So, and now this is about the influencing. So you're influencing across the organization. So this is like building your communities of practice. This is doing your learning lunches, all that kind of stuff. Okay. And then finally, in an organization then. So an organization, wherever you work, has values. That may be one of the reasons you joined that company. Okay. Do you project those companies' values? And as a nice little kind of rule of thumb, in terms of are you proud of where you work, would you proudly wear a T-shirt with your company's logo on it? Okay, I know lots of people who would. I know several people who probably wouldn't. Yeah, or who would be completely indifferent because they just sort of, they work somewhere, it's neither great nor whatever. But that organization has values, right? And so, your values are either aligned with them or not. And if they're aligned with them, you should be projecting those values. You should be walking down the street and someone says, oh, that's a so-and-so person. They must work at that organization because of the way they conduct themselves. And so you care about the organization's reputation. It matters to you. You take it personally, right? And so that means that you get out there, you get out into the world. There's a lovely phrase, a destination employer. Making your company a destination employer is kind of exciting. So that is somewhere that other people would want to come and work. I have an idea that I'd like to do with a couple of my banking clients. I'm calling it the reverse Cockcroft maneuver. Okay, so Adrian Cockcroft was at a conference not unlike this, and he was talking about Netflix and some of the cool stuff they do, because he loves talking about Netflix and the cool stuff they do. And someone on the front row, they put their hand up, and he's doing a Q&A, and they said, oh, but Mr. Cockcroft, you've got all these incredible engineers. I'm just a bank. And he looked across the front row, and he's looking at the company names on the people's kind of lanyards, and he said, I got them all from you. Right? And he said, I got them all from you, and then I got out of their way. Yeah? And because that's what he did. These people were really high-performing engineers. They were really frustrated. Their organization didn't get quality, didn't get why you'd want to care about this stuff. And so they all went off to somewhere cool, like Google or Netflix or whatever. So I'm proposing the reverse Cockcroft maneuver, which is I want to make some banks, some of the places I'm working, so cool that we're going to start hiring like Netflix and Google engineers because they're going to want to come and have more fun, right? Because they can do more meaningful stuff. Because again, this isn't moving a bunch of money around. This is creating the infrastructure whereby you can pay your mortgage, or you can get your money moved around, or you can send money to your family in India or back to your family in wherever else, because we've created the financial structures that can do that. And well, I won't say too much because it's all ongoing at the moment, but I'm hoping in about a year or so's time I'm going to have some really exciting stories for you. So, but not all the knowledge, because you've got to be careful about IP and stuff. Yeah. So when you are speaking externally about your organization, be aware that you're speaking about your organization. So, and again, you contribute to the organization in those ways. So you're all those things. Okay, you're a developer in a team, building a product on a platform, in a department, in an organization. You're beyond developer. I love this quote. It's saying, if you want to go fast, go alone. If you want to go far, go together. If you want to go far quickly, pack light. That's what I think. But yeah, if you want to go fast, go alone. If you want to go far, go together. Thanks.